Hello and welcome to Module 4, Modeling and Simulation. Today we will talk about simulation using Arena modeling tools. For the behavior of Arena, first of all, you will start Arena, load, explore, and run an existing model, fundamentally comparing to hand simulations, browse dialogues and menus, running the model, and then look at the results. You can also construct a model from scratch. You can use these basic building blocks in case study to address real operational questions. We'll go through the menus, toolbars, drawing and printing, the help system, and then options for running and control. Arena is a true Windows application. Its appearance, operation, and functionality are very standard with Windows and behaves much the same way as other Windows software programs do. If you're familiar at all with Microsoft Office or AutoCAD, it'll give you a very similar appearance and your learning curve will be a lot less. So it also assumes that you know the basics of Windows. Everything from disk files, keyboards, mouse, keyboarding, moving, maximizing windows, menu operations, Control, Alt, Shift keys, copy and paste, and filling out dialog fields. Those are all basic computer literacy requirements that, of course, are expectations for this course and for using Arena simulation. In starting out, make sure to install the Arena software. If you have not done so already, the instructions for doing so are available on the Blackboard page. You should be able to sign up for a free trial, or if you want to use it for later work, you can also purchase a student version. Locate the icon or shortcut and double-click on it, and then look through the File, View, Tools, and Help menus. I would encourage you throughout the course of this particular lecture video to pause and then play around with it and try the different menus and their compatibility and what it can do. In order to quit Arena, you can always go File, Exit, Alt F4, or just click in the upper right box, just like any other Windows software program. Opening an existing model is under the File or Open, or click on the Open button. Navigate to the desired disk or directory, and then you'll see that we have the Open a Model 03-01.doe. .doe is the file extension that Arena uses for simulation files. You can get examples in the student edition for bookexamples.zip, which should be available online at that location above, or you can get more examples through your software program that should be saved as part of the software installation. On the right is the model window, where the model itself will be built. This is where you go and create the actual model itself. You can cut and copy and paste components within Arena and between Arena and other applications. This is very handy for when you're creating very complicated models and you have to go and create multiple iterations or parallel systems. You may have already created some of the model in one place. If you can just go and copy and paste elements, you don't have to rekey it. Also reduces the risk of transposition error. Flowchart and spreadsheet views can be split in the model window. The flowchart view shows graphics, the flowchart, animation drawings, and then edit things by simply double-clicking on them and into a dialog box. The spreadsheet view displays the model data directly. You can add, edit, or delete data in that spreadsheet view, and it displays all similar kinds of modeling elements at once. Many model parameters can be edited in either view, and it becomes a case of either user preference or based on what is simpler for the particular application. The horizontal splitter bar to apportion the two views, and you can also change the views with that button to see both the flowchart and spreadsheet views. The project bar is typically down at the left edge of the Arena window. I say typically because it can be drag and move, so if you have a personal preference, you can move it elsewhere. This hosts panels with modeling building blocks, so the modules. This display, you can display one panel at a time and switch to different panels using the horizontal buttons. Again, it's usually docked to the left edge, but can move or float, and you can always hide it by viewing project bar or click on the upper right. For the same token, if it's hidden and you need to bring it out, you can go to the View Project bar and turn that on there again as well. The status bar is at the very bottom of the Arena window. It displays various information sensitive to status. So it coordinates the cursor in the workspace, and while the simulation itself will be running, it will show the clock value, the replication number being executed, and the number of replications being done. This is beneficial for you as you're running your simulation because you can watch it unfold and you can have an idea of how far it's going. At the same time, if your simulation is very complicated and or a long runtime, you can also see progress and get an idea for how much of the simulation has left to go. You can always hide it or unhide it by clicking under View or Status Bar. So moving around, up, down, or in the flowchart view of the model window. This is the underlined world space for the model and uses XY coordinates, similar to AutoCAD or Visio or similar software programs that you might have seen using spatial layouts. You can pan with scroll bars or arrow keys. You can zoom in or down using the buttons provided, or you can use the roller bar on a mouse or other ways that you would typically zoom in a Windows software program. You can see all by clicking on the buttons or hitting the star key, and then also have named views. So you can save a particular zoom view of your model. This is also a beneficial trick to know, because if you save your model view, you may be able to go back to it while you're making changes to other components within your model. It also includes a display grid, snap to grid, or rulers, alignments, guides, and text. Again, these are very similar to Visio or even tools within PowerPoint to move things around visually and spatially. The basic building blocks of the simulation model are the modules. And there are two basic types, flowchart and data. The different types of modules are applicable for different actions or specifications. You can create blank modules on the project bar. So for example, adding a flowchart module to a model, you can drag it from the project bar into the flowchart view, or you can use a data module by selecting it in the project bar, editing it in the spreadsheet view of the model window. The flowchart models will describe a dynamic process, which we discussed earlier on in the previous lecture. The dynamic process will show the nodes are placed through the entity's flow and will typically be connected to each other in some fashion. The basic process panel flowchart will show different types such as create, dispose, process, decide, batch, separate, assign, and record. Other panels are available in many other kinds. Shapes are typically like flowcharting symbols, where you use a square for an operation, a diamond symbol for a decision tree. Triangles oftentimes reflect inventory queues, and so on. There are two ways to edit these. You can simply double-click and open up and fill out the dialogues, which most people find very easy and the simplest way to go. But you can also hit single-click and then in a model or project bar, and then get all the modules of that type in the spreadsheet view. The set values, conditions, etc. are within the data modules. These will be set right here for the use within virtual modeling. The basic process panel will display data module types, including attribute, entity, queue, resource, variable, schedule, and set. These are common simulation terms which we've discussed previously in the lectures and are also included in your assigned readings. Icons on the project bar will look like little spreadsheets, and to simply use a data model, you can select it with a single click in the project bar or edit it in Spreadsheet View. At most, one instance of each kind of data model can be in a model. However, each one can have multiple entities, numerous rows within. The relationships among the models include flowchart data models related to via names for the objects. So queues, resources, entity types, variables, expressions, sets, and many others to choose from. Arena keeps internal lists of different kinds of names, and this presents existing lists to you where appropriate and helps you remember the names and protects you from typos. Again, Arena is designed to help make it easier for the user for complicated models. All names you make up in a model must be unique across the model and even across different types of modules. In the internal model documentation, data tips on modules and graphics can be seen by simply hovering the mouse over the object to see. They'll also give you options of default parts, generic names, user-specified parts, or you can toggle display of data tips by simply hitting View and Data Tips. Project descriptions can be found under Run, Setup, and Project Parameters, and then you enter the text. And model documentations can be found under Tools and Model Documentation Reports. The documentation will typically result in an HTML file with all the details from the modeling. So browsing through the model 3.1, let's go and open up model 3.03-01.doe in the Book Examples folder. There will be 3 flowchart modules: the create, process, and dispose. Entries in 3 data modules include entity, queue, and resource, and the animation objects include resource animation, 2 plots, and some passive labels or artwork. So to create the flowchart model, you first give the birth node for the entities. Gave this the instance of create type module for the name part arriving to the system. And if we had other create modules, which in this case we don't, they would all have different names. Again, in this case here, we're starting with a simple model. However, as you get more complicated, you have to make sure to give them independent names so the software knows that it's something different. Double-click on the module to open the property box, and you can see the information included below. Include the name for the module, the entity type, the time between arrivals, the entities per arrival, the max arrivals, and then the first creation. Again, make sure that the time of the first arrival is when you want to begin your simulation. It does not need to be 0, however, it can be. Editing the flowchart modules in Spreadsheet View is an alternative to dialog box in each instance of a module type. Selecting this module in either Flowchart or Spreadsheet View will also select it in the other view. You can click or double-click the view fields to edit it, right-click in a row to edit via dialog, and then right-click in expression fields to get an expression builder for help in constructing complex expressions with arena variables. A data module can only be edited within the Spreadsheet view, so make sure that you select that. So view and edit the aspects of the different entity types in your model. In this case here, we only have one entity type in part. Pull-down lists are activated as you select, and our only edit will be our initial picture for animation. We picked picture.blueball from the default list, and you can see that under Edit and then Entity Pictures to change that if you like. The process flowchart model represents machining, including resource queue and entity delay time, which in this case here is processing. The entity delay time can sometimes be confusing because when people look at delays in simulation, delay usually means wait or hold times. In this case here, you're considering with the entity, which means the entity is performing an action. And so we're recording that action as a delay because how long you have to delay your performance for that particular action to commence. You can enter the names for drilling center. The type will be picked standard to define logic here rather than a submodel. And then report the statistics checkbox at the bottom. The statistics checkbox will be used to get utilizations, queue lengths, queue waiting times, or whatever data that we choose to output. The logic area is what happens to the entities here. Under Actions, Seize, Delay, Release, the entity seizes some number of units of a resource. The delay itself is there for the processing time, as we just discussed, and then release it once it has been seized. So choose this option. For example, a delay entity, a red traffic light. So no resources, no queuing. However, it just cannot move forward in the system at that time. A seize delay would be no release. Presumably a release will be released downstream. And then a delay release will be if the resource has been seized upstream. The priority for seizing would be the lower numbers. So the lower the number, the higher priority for seizing. Different action choices could allow stringing together several process modules for modeling flexibility. For resources, define the resources to be seized and released by double-clicking on a row to open the dialog box, defining the resource names and the quantity of units to be seized and released here. Several resources can be present, and you must first seize all. Delay type, the choice on probability distributions, constant or general expression, the units, time for delay, allocation, how to charge delay in costing, prompts on next line, change depending on the delay type, so specify the numerical parameters involved. You can also edit these in Spreadsheet View. All these would be dictated by your particular system that you are having to evaluate, and some might be more applicable than others. For example, costing is always critical, but if time may be your more critical element, costing may not be as significant a factor within your system. So defining the drill process resource in the process module automatically creates an entry row for it in the data module. You can edit here for more options. So you can change the type, you can change the capacity, and you can change the failures, which cause a resource to fail according to a specific pattern. You can define all those pieces here. Specify the aspects of queues within the model. Here we only have one, and we've named it drillingcenter.queue. That's the default name that the process module name. The type specifies the queue discipline or ranking rule. If the lowest or highest attribute value, then another field will appear where you specify which one to use. Shared, if this queue will be shared among several resources, or if it's independent and only to this particular resource. And the report statistics will check for automatic collection and reporting of things such as queue length or time in queue. Animating resources and queues. You've got the queue animation symbol right here, which automatically specifies by C's in the process module. You don't get the resource animation automatically. In this case here, you have to go and add that by clicking on the resource button in the Animate toolbar. From there, you use the identifier to link the resource name in the pull-down list and specify different pictures for the idle or busy states. If you want to use predefined artwork, you certainly can, but you can also combine or create your own. To edit later, you can always double-click on the picture within the flowchart view to change it if you prefer. The Dispose flowchart module represents entities leaving the bit model boundaries. So here you name the module and then decide on the record entity statistics. So how long, average, maximum time the system entity is exiting here, costing information, and so on. See the checkboxes for statistics and collection reporting. Most are checked on by default, but you may want to revise that based on your particular module. Connecting the flowchart models, establish a fixed sequence of flowchart modules through which entities flow. To make a connection, use the Connection button or the Object Connect in the pull-down menu, and the cursor becomes crosshairs. You then click on a point from one source module and then drag it over to another entry point on the destination module. You can use intermediate clicks for non-straight lines and segments if necessary. You can also make many connections, which may be handy if you're making a rather large model, where after each connection you can simply right-click in the blank space and then select Repeat Last Action from the pop-up menu. Or when you click on the button originally, the object, you can double-click on it and then place multiple connections, and then get out of that mode by hitting Escape. The object menu toggles. AutoConnect will automatically connect entry point of newly placed module from exit point of a selected model. Smart Connect forces segments to horizontal and vertical, which could be helpful when you're laying out your model. And then Animate Connectors will show entity moves along the connectors. The move entry exit points relative to their model. You can right-click on an entry or exit point, and then just select Allow Move from pop-up, and then drag the entry or exit point around. Dynamic points. You can trace variables such as queue lengths as the simulation runs. They will then disappear after the run ends, but you can keep them by saving the data in the Output Analyzer bar. I won't go into the Plot button on the Animator toolbar. I would encourage you to go explore the different tabs that you can go and use within your model. On the Axis tab, the X-axis is always the simulated time. You can scale it, and on the right, you can hit by hitting the plus button and then specify your minimum, maximum, your increments, and your auto scroll options. Your Y-axis is on your left. So note the probability for the different Y-axis scales for the multiple curves. The Legend tab will show the legend box, since we only have one curve here and the Y-axis is labeled. And then other tabs such as titles, areas, 3D view, etc. I encourage you to pause the lecture and to explore some of those options as well. So cleaning it up, you can add a drawing objects from the Draw toolbar, similar to other drawings and CAD packages. If you've ever used something like AutoCAD or even Visio or possibly even Microsoft PowerPoint at a very simplistic level, it looks very similar. You can use text to annotate and control the font size, color, orientation, etc. to improve the appearance of the model. Setting the run conditions. Under Run and Setup, this is where that model option it lays. This is where you enter in project parameters and replication parameters, all the basis within your project or within your model that you need to simulate. There are different tabs for speed, run control, reports, array sizes, and visuals so that you can run the model very quickly, or if you want to watch it visually as the model produces. When running your model, you can run it simply by hitting the play button from the standard toolbar. Other buttons such as stop and pause should be fairly intuitive. There are other run control and viewing checking options to consider. Viewing the reports, at the very end, at the end of a run, make sure to click Yes on the Arena box to view the reports. This will open them in a new window and will show the different reports that you can consider. Remember, close all those reports windows before future runs. The default installation shows a category overview report summarizing a number of things about the run, but you can also go and change those depending on the nature of your model or of the system that you are trying to simulate. Some examples in the reports might look below, where you can see the entity, the time, the total part, and the average time in the system, along with the maximum. Again, I won't go through all these individually here, but play around with these when you run the simulation to see different ways that you want your reporting to view. The types of statistics reported give one of three types. You can give a tally, which is simply basic statistics of average, maximum, and minimum, or discrete list of numbers. You can give the time persistent statistics, which are time average, max or min of a plot or something like that in a continuous basis, or a counter, accumulated sums of something. So how long something had, how many people went through queue, how many times this particular application got held up, or how many wait times occurred. All those may be valuable for different reasons depending on the system that you are trying to model. Let's go through a case study. In this case here, we'll use loan applications, which go through 4 steps: credit check, prepare the covenant, price loan, and then disperse funds. Each step will take approximately 1 hour, and then applications arrive with the expo of 1.25 hour inner arrival times. We'll consider for the simplistic case here of the first application arriving at time 0. We'll want to run the simulation for 160 hours and watch the average, maximum number of applications in process, or that work in progress, the average, and the maximum total time in the system of applications. In this case here, we'll assume that there are 4 employees and each of them are able to do any of the process steps. So consider this simulation as wanting to understand the serial specialized processing or the generalized parallel processing. Essentially, what is the effect of service time variability on this decision? So let's look at model 03-02.DOE. You can create the module, which is similar to module 3.1, except the expo, mean, and time units are included here. Set the entity type to application. Create the 4 process modules similar to model 3.1 using 4 separate resources. The expo process time will be an expression via the expression builders. The dispose module time you can create similar to model 3.1. Use the default entity picture. The report is okay. The default resource animations are almost okay, with a minor change of making the idle picture the same as the busy and selecting the correct resource name in the identifier field. The queue, resource, and data modules are okay. The plot, WIP, or work in process, use the expression builder to find entities, WIP, and application. We want a fixed y-axis maximum of 25 to compare with the next 3 models. And then fill in run setup and lengthen the queue animations appropriately. For model 3.3, we'll create the general parallel processing. So this is 03-03.DOE. So create, dispose, plot, and then run setup are almost the same. We just have to change some labels. So replace the 4 earlier process modules with just a single process model. In this case here, we'll use 1 resource, the loan officer, but 4 units of that. So we're going to have 4 of the same resource in this instance. Still set quantity to 1 since the application needs just 1 officer, and the delay type expression is expo 1 plus expo 1 plus expo 1 plus expo 1. The reason that we don't need 4 times the expo 1 is because this is not considering these are considering 4 separate resources, not 1 resource with 4 times the capacity. That's a very important distinction. Modify the resource animation for 4 units. Open model 3.2 resource animation to get the resource picture, placement window, and then open the idle picture. Duplicate the white square 3 times and then realign them and then copy them to busy. And in the model window, double-click the C's area, then add 3. Still not completely accurate animation. We need the sets. So a note of caution here, this is from only 1 replication of each configuration, so there is some output variability. From what you see below, do you see that the differences are statistically significant? In looking at the two, logically speaking, the average is substantially different from one to the other. The total work in process goes from 12.39 to 4.61 in a series versus parallel system. The total waiting time is even more dramatic, 11.98 to 1.33, and the number processed is about the same. So consider the effect of task time variability. Is parallel always better than serial under any conditions? In some cases, yes, and in some cases, no, and we won't delve into that at this exact point. So now let's look at the task time, or the expo, which is approximately an hour. Let's consider the distribution and make it a little bit more variable. In this case here, let's say that there's a 0.15 or 15% probability that the task time could be less than 10 minutes, but a 0.14 or 14% probability that the task time is greater than 2 hours. In a serial configuration, just one large task time will configure everything, whereas in a parallel application, one will create a bottleneck, but things will continue to flow through the other parallel applications. The other extreme is when the task time is exactly 1 hour. In this case here, you leave the interarrival times as the expo of 1.25 hours, and then a series system will be very effective when there's very little variability. For constant service, a parallel improvement appears minor, maybe even not statistically significant. So further questions that we could go into without diving too deep into here. I won't go into all the different nuances within the menus, but I encourage you guys to spend a few minutes playing around with the software and getting to know it better. Here is the files options under Menus, under File, Edit, View, Tools, Arrange, Object, Run, Window, and then Help. Many different options on toolbars. Again, I won't go into a great detail here, but I'm including this text in here for you to reference as you're running your models. Same with the drawing toolbars, Printing, Help, and more on running models. Here's options under the Run menu, standard toolbar interaction toolbars that you may get to use.